Okay, example 7. We have a graph of acceleration A versus displacement x. And this graph shows that it is a straight line graph with negative gradient passing through origin. Okay, the moment we see this graph, it's a straight line graph that passing through origin with negative gradient, we immediately recognize that this is a simple harmonic motion. Okay, because a simple harmonic motion have this kind of graph. Okay, part A, state the amplitude of the oscillation. Amplitude is actually the maximum displacement. That means the maximum value for x. What's the maximum value for x? You look at the graph, maximum value of x is 5.0 cm. So that's the answer, 5.0 cm. If you want to change to meters, it will be 0.050 meters. Part B, determine the period of the oscillation. Okay, there's something you need to know about this graph, A against X. We know that the gradient of this graph is going to be negative omega square. Okay, so what we do is we're going to work out the gradient of this graph equate to negative omega square. So negative omega square is the gradient. And gradient, it'll be easier if you just use half of the graph. So it's minus 10 over 0.050. Okay, we now have to convert to meters because we want our answer to be in seconds. Okay, so we work out the minus omega square is actually minus 200, and then the negative sign cancel away. So omega square is 200, and omega we know is 2 pi over t. So from there we can find the t, which is the period, 0.44 seconds. Okay, next, part C, they ask us to determine the maximum speed of the object. Okay, yes, there's a formula for the maximum speed. Okay, you can refer to the summary of all the formulas. Maximum speed v naught is equal to omega times x naught. Okay, omega we have just found. Omega square is 200, so omega is square root 200, and x naught is the amplitude, 0.05. Okay, everything convert to meters. So we get 0.70 meter per second. Okay, so that is the example.